All right, folks. So this is the last session of the two-day workshop. And I'm going to talk about a few other features of Scenic and Verify, and also some other associated tools, some of which we've actually mentioned in some of the discussions, but I'll show you some results as well. Okay. And then I'd like to have a bit of discussion. So we'll do a bit of presentations, and then we'll spend the rest of the time in some discussion, and then we'll do hopefully we'll have time for a quick survey of feedback from all of you on the workshop. Okay, great. So when Daniel introduced Scenic yesterday, the dynamic scenario features, he talked a little bit about the compositional aspect, that you can define scenarios and you can combine scenarios, simple scenarios into more complex scenarios. And so, so we have various kinds of composition. There's parallel composition, where you can take two scenarios, for example, that might be happening in different parts of the map or in the workspace, and you can compose them in parallel, meaning they happen simultaneously, right? But potentially in two different areas. You can also have, it can also be in overlapping areas, but then of course you have the interacting constraints that one has to deal with. You can do sequential composition, which means you can have one thing happen after another, one scenario happen after another. And so here's what the syntax looks like. I think Daniel might have introduced this, but it might have been a little quick yesterday. So for instance, here I have two scenarios, a stop and start scenario and a badly parked car scenario. And now what I can do is I can, in the first case, compose them in parallel, so they happen simultaneously, concurrently. In the second case, I do the stop and start first and then a badly parked car next. Or you can actually have this form of composition, which is, you can think of it as a hierarchical composition or a conditional composition, where you have one scenario, which is the stop and start scenario that begins, but then at some point that scenario can get interrupted, and then you go and execute a different scenario, and then you come back. Okay, so very similar to behaviors, right? That you can have this sort of try-interrupt composition, but now this is happening at the scenario level. Yeah.
Does it take the vehicles from the first scenario and then put them into the second scenario? That's what I'm assuming.
They don't get destroyed. The objects that were created in earlier scenarios continue to exist for the rest of the simulation.
Yeah.
Okay, but it won't be like the car that was stopping and starting, the eco car there, and then becomes the eco.
It is, so you can have continuity of that nature.
Yeah, I mean, each scenario can have its own ego car. So it's not like assigning ego in one of them will mess up what's running in the other one. If that makes sense.
No, but I think she's talking about sequential composition, where so the question is, if you have agents in the first scenario and you want them to continue in the second scenario, you can reference, and you can. Right.
You can write the scenarios in a way that there's like a single ego car used throughout, but then each scenario has its own additional cars being added, for instance.
Oh, okay. So for this, you could define the eco outside.
Stop and start. Right. You might have that at the beginning, and then the other ones are just introducing new interactions.
Right.
And in fact, I think we have an example of exactly that in the tutorial on composing scenarios.
Yes.
So if you look at the doc, we've got 3 tutorials: static, dynamic, which basically we did yesterday. The third one we didn't do in this workshop is on compositional scenarios. So I would look there for examples of that kind of thing.
Would it be a way to somehow have the vehicles kind of be passed in between these, such that if you do have like a set of vehicles created in the stop and start, you could pull those out and then pass them into that?
You can also do that. So these can take arguments just like behaviors, and so you can say, you could have a pedestrian jumps out at you scenario that takes as an argument, which car should it jump out in front of? And then you could have that be used several times, targeting the same car or different car.
Okay, so let me just repeat the question for the recording on Zoom. The question is, can you have objects and agents in one scenario passed to the next one? And the answer is yes, you can do that. Scenarios can take arguments. and you can instantiate those in the subsequent scenario. Okay, great. So there's documentation on the Scenic website on that, but what you can also do is use this with Verify. And this is a feature that we plan to have in the new version of Verify, which is compositional falsification and compositional statistical model checking. So this is work that actually was published in fall of 2023. And there we had this scenario, which, okay, unfortunately I have the image, but not the video. But this is a scenario that we constructed in the WeBot simulator, where there's, as you can see up here, on the top, there is a four-way intersection. And what you're seeing in the big picture is you have a red car, a maroon car that's following a black car. And so the black car is the environment vehicle, and the maroon car is the ego vehicle. And then they go to the intersection, and at the intersection, the black car can randomly choose to go left, go straight, or go right. And there are obstacles as well on the road. And the maroon car has to safely follow the black car and avoid all the obstacles. So that's the scenario. Now, this scenario in WeBots can take several seconds to a minute to simulate. But what you can do is you can chop it up into sub-scenarios. So the initial sub-scenario is the approach to the intersection. And then one sub-scenario is going left, another sub-scenario is going straight, the third one is going right. And you can construct that in Scenic. And then what you can do is you can run falsification on the individual segments in parallel, right? And those of us who worked on falsification know that a falsifier essentially does the sampling, active or passive sampling in a loop, and has to run many simulations before it starts to find failing simulations. And so that can be a big cost, especially as you start to do very complex scenarios. And so this is a way of exploiting the compositional structure in Scenic to speed up and massively parallelize the search for unsafe situations. Okay, so just wanted to mention that work. All right, the second work I want to mention is actually was led by Karim, who's here in the audience. So this is Scenic NL. We didn't really have a formal presentation of Scenic NL yet, but Scenic NL is a system that takes English and turns it into Scenic code. This work was published at Column 2024. And so one of the results that Karim worked on was to essentially scrape 500 California DMV crash reports off of the website and then turn them into Scenic programs. And I'll just show you an example of what it did. And so here's an example. If you can read the scenario at the top, it says a Cruz autonomous vehicle operating in autonomous mode was driving eastbound on Clay Street at the intersection with Kearney when it slowed down. The driver of the Cruz AV disengaged from autonomous mode, and shortly thereafter, a bicyclist proceeding straight made contact with the right rear fender of the Cruz AV, damaging its fender. The bicyclist left the scene without exchanging information. Okay, so that's the scenario. And then I'm sure all of you have been not listening to me, but watching the video played down there. And so that's the recreation of what happens in Carla when you run the generated Scenic code, which is on the left. And it's, as you can see, it's a reasonable recreation of this because there is a bicyclist and there is a car, and the bicyclist does hit the fender and does leave the scene, right? So those aspects are there. But there's a lot of details that are not quite accurate, right? So it's not really at the intersection. It's not the right rear fender and so forth. Okay, so that's Scenic NL was able to basically generate a lot of these Scenic programs, but then they require further review and editing to get it right. But it gets pretty high accuracy of syntactic correctness. So this is something that complements the work that Sridhar mentioned on their Road to Code project, which does something very cool in going from video to Scenic. There's actually, over the last year, I got familiarized with even more projects that are doing this. So there is work out of Toyota and University of Illinois on a similar pipeline. So here they take video data and they turn that into Scenic code. So this is your script GPT. And then the Scenic code runs in Scenic and in a simulator like Carla and produces simulation video. And here's an example of what they did. So if you look at this video here, actually, if you might want to look at this screen, it's a little clearer. So what happens there is there's a car driving, there's two cars in front and a pedestrian crossing, and then one of those two cars does an unsafe maneuver right in front of that pedestrian, right? So that's the scenario, and it turns that into Scenic code, and then it produces the following video in Carla, which is again reasonable but not fully accurate recreation. So in this case, the pedestrian's crossing, there's only one car in front, and that does the unsafe maneuver in front of the pedestrian, right? So that's another pipeline, generative AI pipeline generating Scenic code from data. And then there's a third paper that was at CVPR last year that also does text to Scenic, but I don't have any results from this one. Okay, so there's at this point, there's multiple tools that we're aware of that are translating into Scenic, and I think it's a good opportunity for us to kind of build on all of these and certainly improve the state of the art in terms of easing the way in which we can program in Scenic, right? As people said last night, like we want these AI tools to help us generate these scenarios from artifacts that people already have. All right. Okay, and then the last thing I want to mention is actually work led by Edward Kim. So Eddie, several years ago, did work on querying images, labeled image data with Scenic. So the idea there is, imagine you have a large data set of sensor data, in this case, image data, and it's labeled. Maybe it's not labeled perfectly, and some of the labels may be wrong, but you have some labeled data. And now you want to search for a particular scenario in that data set. So the old work, which is published in 2020, was on image data. The newer work, which was published just this year, is on video data. And so the idea here is that you have a Scenic program for a scenario, and then you've got labeled time series sensor data. And so by the labels, what is meant is that, again, if you look at that video that's playing, so here it's a video where all of the objects have bounding boxes over them, and those bounding boxes have associated labels, right? So the idea is that somebody or some AI has labeled this video with all the objects in each frame and bounding boxes for them, and those are the labels. In addition, typically you also may have some telemetry data associated with the position and orientation of the vehicle and its velocity and all of that. So you have all of that data, and that's your trace. And now we want to, and we have lots of those traces, and we want to be able to identify from that set of labeled traces, which of those match the Scenic program. Okay, and in this case, the match is something that is just a Boolean match. It could be, ideally, would like more than that, but for now, we just want to say, oh, there are some characteristics of this video that match some portion of the Scenic program. So it's like a partial match that we're evaluating for. And so the details again are in that paper, the NFM paper. But what I want to do is just share some results. And actually, Eddie, do you want to talk through this slide? Yeah. So there's 4 videos here, and maybe I'll just play them and you can talk about it.
Okay. So regarding the data set, we use a new scenes data set. And as you can see, these are the play of the videos from the data set, which has all these labels there. And for example, the first one is the car is going straight, and then there's another car stationary in front, so it has to make a lane change in order to avoid that car and then keep going straight. And likewise, we have 4 different scenarios that we looked at in total. And we benchmarked our algorithm, the accuracy of algorithm. So meaning, given this time series sensor data, we have a Scenic program, and then we're trying to determine, okay, is this time series sensor data, could this have been generated from this Scenic program? Right? Is it a yes or no? And right now we benchmarked it against two large language models, multimodal large language models, Claude 3.5, I believe at that time, and then GPT-4o, which were the state of the art back then when the experiment was conducted. And the numbers that you see, so on the left column, you see the scenario numbers, 1, 2, 3, 4, Claude, GPT-4o, and our algorithm. And the numbers inside represents the accuracy. So it's out of 1. So if it's 1, it means it's perfect in terms of accuracy. And so what and then on the row below, it shows the average accuracy across these 4 scenarios with a mean plus minus standard deviation, and then the average time, the query time, to actually determine the membership between the time series data and the scenario itself. So what we're seeing is that our algorithm is indeed performing better than the state-of-the-art video large language models. And also in terms of the query time, it's 2 to 3 orders of magnitude faster. And you may find this comparison to be unfair in a sense, because for the Claude and GPT-4o, we're feeding in the actual video, whereas for our algorithm, we're feeding in the label trace. And that's why it's faster, but that is actually the point. There are data sets out there that are already labeled. So by using those open source data set, you can indeed enjoy this benefit of querying more accurately and also much faster. So that was a point of this. Yeah.
Okay, great. So, all right. So that's the quick overview of a few other projects that I wanted to talk about. Let me just say one thing about this. Let me go 2 slides back. The querying project. I think there's a lot more to be done here. So this is really like version 0.1 of the querying algorithm. I think there's much more to be done in terms of scaling things up. So one of the places that it can be a little tricky is there's a lot of objects in the Scenic program. There's a lot of objects in the video, and only a subset of objects in the Scenic program has to match a subset of objects in the scenario. So you have to pick k out of n here, and then p out of m here, or k out of n here, and then you have to match those together, right? So basically find a permutation that matches. So you can see that this can combinatorially explode on you, and so that's one axis of complexity, and then the other axis of complexity is that you would ideally like a more quantitative notion of a match, right? So it's not just Boolean, but you want it to be to give some degree of match. And I think that is something that is yet to be defined. So there is still a lot more to be done on the querying side, and we would love to collaborate with people. If this is a problem that seems like it's of interest to you, and I think it could apply across domains, of course, so we'd love to collaborate with people on this. Okay, great. So any questions about any of these things? No? All right, so if not, what I'd like to do is just move to some discussion. And so we can just have a bit of an open discussion for half an hour, or as long or short within that range as we need. And so
Yeah.
any topics that people want to bring up?
We're interested in if there are things based on, hopefully now everyone has at least the basic understanding of the kind of features in Scenic and use cases and so forth that we've considered, but if there are features missing that would be useful to you, or ideas you had based on things you've heard in the workshop, we'd love to discuss those prospects for that. Oh,
I stopped sharing, but what's that? Oh, Vaishali, okay.
Hold on a second, Vaishali.
Yeah, should I mute on my end here?
Yeah, and I'll mute this. Hey, Vaishali, do you want to try unmuting yourself? Oh, there we
Yeah,
go.
can you hear me?
Yes, we can hear you.
Yeah, this has been an interesting workshop and hands-on exercising sessions. Just a very high-level question. Are there any ongoing projects or activities going on of using Scenic in the urban airspace mobility environment? More to do with the aviation? I know there was a talk earlier today where there was a project that was presented which briefly touched on it. I was just curious at a very high level if there have been other activities going on along those lines.
Yeah, thanks, Vaishali, for that question. So the short answer is yes. We have ongoing projects where we are interfacing Scenic with air domain simulators. So Daniel could probably say a little bit more about the work that he's been supervising in the Citrus Aviation Challenge. At Berkeley, we have a DARPA project in which under which Scenic has been interfaced to AirSim in particular, but more generally to there are people who are interested in interfacing Scenic to air domain simulators. There's a team, or even actually I should say multi-domain simulators. So there's a team at Lockheed Martin who is using Scenic for air domain, and in fact, combinations of air and ground domain. And unfortunately, they couldn't logistically make it to present today, but that's one user that we are supporting. And then in this DARPA project, like I said, we have this simple Scenic AirSim interface that we've been using to work on some of the challenge problems. But this is definitely an area of interest.
Yeah, I agree. And I think, as Sanjit mentioned, we do have a prototype AirSim interface. A master's student of mine, Mary, who subsequently graduated, did the interface to AirSim and did some experiments, simple experiments with drones moving around in kind of a toy example of a city. And then some of the Berkeley folks have been building on that interface, as Sanjit mentioned. But we don't have that publicly released yet, but we've been actually recently looking at cleaning that up and getting that ready to release. So I think, I guess one question that I would have for you is like, what kind of simulators or are there simulators that you're already using in your work that might make sense for us to look at?
So on our end, we have tried using AirSim, but it's a more general question in the sense that some of the sensor data that is being used in the automotive world, some of it could be potentially similar kind of research is applicable to even the airspace domain, right? The only thing is probably interfacing with the simulators, it makes it easier to get the physics specifically related to this airspace, right?
Right.
It'll be nice if I can get a little bit more information about those projects, maybe offline via email. Thank you, Sanjit, and thank you, Daniel.
Yeah, happy to send more on that. And as I said, we're hoping to have the AirSim interface along with some examples released in the next month or two. And then the Microsoft Flight Simulator is more tentative. We're not sure about that. And it was the X-Plane interface that was mentioned before, which exists but hasn't been updated to the latest version of Scenic. That we don't have anyone working on that at the moment, but that's also potentially something we could look into. I think all of those simulators, do reasonable like physics simulation. I think in the case of like X-Plane, there's X-Plane and Microsoft Flight Simulator especially. The part that actually I think has been hardest for us when we have tried doing simple experiments with those is just not having good software to plug in to control the drones or whatever it is. So like I think with Mary's experiments that I mentioned, it was with quite simplistic controllers where it was just essentially AirSim had some controller for flying a quadcopter from point A to point B.
That's correct.
But we didn't have like a more interesting system that could actually do planning to avoid buildings and navigate in some interesting space. So we couldn't really test interesting scenarios like deliver a package in this dense urban environment with other vehicles moving around, et cetera. So that's something we'd be very interested in collaborating with industry on. Like if you have systems that are designed to be able to carry out those kinds of tasks, it would be really cool to test them with Scenic, because with just the simplistic sorts of things that come with some of these simulators, it's only really quite simple scenarios that that make sense to test them with.
Right. Or if you know any open source autopilot software that works well with some of these simulators, that would be great.
Yeah, but like not just autopilot, but planning, right? Because we also did experiments with PX4, for example. That's another autopilot. But again, it's just, at least the functionality we could find, it's like fly from point A to point B in a straight line, more or less. Not like get from here to there while avoiding collisions with a bunch of other things that are moving around in the same space. So there's no sensing or interesting planning going on.
Yep, that is correct. Yeah, that's the area that we are also trying to look into, and it'll be nice if we can figure out something. So thank you.
Okay,
Yeah, let's follow up.
Let's be in touch.
We can actually, add the air domain to the robotics and other domains. So cover that as well.
So we're hoping to set up regular meetings of those, and we have actually talked internally in the team about making like an aviation domain, some library to help people write aviation scenarios that again would work across multiple simulators. We're hoping to start monthly meetings of those, and if you or any other folks here or that you know of that are interested in this might be interested in being part of that, do let us know.
Sure, thank you.
I know most of the people in the room were at the discussion last night, but I can very quickly summarize some of the things that came up. So one thing that came up yesterday, which I already mentioned, is better support for authoring scenic scenarios, leveraging the code generation capabilities of LLMs and VLMs. As you can see, there's already stuff that we can build on. There was a lot of discussion about game development and applications of Scenic to that domain for different types of game dev. One of the interesting topics that came up was real-time simulation initiated by Victoria. So the idea being here that you actually want Scenic to be able to control a system with real-time latency guarantees for some definition of that, right? And that's one of the things that requires, we realized, is event-driven support. So right now, as was mentioned yesterday in Scenic, you have a fixed notion of a time step, and basically Scenic is polling the simulator at those fixed time steps. And so, actually, are we still unmuted?
This one.
Okay, great. And so that's a bit limiting in cases where the environment or the simulator has an event that happens sometime in between those time steps that you have to react to. So what we need to do is make Scenic respond in an event-driven fashion, not just in a time-triggered fashion, which I think conceptually is possible, right? And this stuff is well known. We just have to implement it. So that I think is a concrete item. Another item that came up is to build a core library of primitives for robotics. I think this there was a probably discussion in the robotics breakout session on this. So I think having our attendees from the Gazebo project here. It's great because I think we can try to think about what that sort of a generic robotics library interface would be like. I think there was some discussion on this in the robotics breakout that I was not part of. So if somebody wants to weigh in on that and summarize, that would be great.
Yeah, I can talk about summarize what the discussion. I have my notes here. So we talked about how we're planning on looking into this. Kai has already started looking into this Roboverse MetaSim system to basically allow us to interface to a lot of robotic simulators all at once. Anirban asked about doing an interface to Isaac Lab because they like to use that in the near future, and it seems like it's very similar to Isaac Sim. So I'm hoping in the fall we can do that. The Gazebo folks asked about like what does Gazebo need to support integration with Scenic, like what has made the integration difficult. So we had some discussion about the Python API and how in our current interface to classic Gazebo we were using ROS, but we can also do that with the new version, it seems. So it seems like there's no real barrier there, and the Gazebo folks graciously offered to help out. So we can look into that. We talked a little bit about how Scenic might be integrated, like as a plugin to Gazebo versus a separate thing. And we had some discussion about dealing with assets. So basically having some library in Scenic that could read a URDF file or Gazebo's format SDF and pull out the structure of objects and the information that we currently get out of various idiosyncratic formats for other things. We had some technical discussion about that. And then there was some discussion, I think, about, I think, Eddie, you asked about applications that Gazebo is currently used in that Scenic might be helpful with. So I think Kat mentioned like hospital and warehouse applications, outdoor scenarios, and I think Ian mentioned that there's a lot of RL applications recently. So the Scenic Gym would be interested in. And then the last thing was Victoria had brought up some challenges with creating cost maps in Gazebo, and I admit I didn't really understand that because I don't know what cost maps are. It's something to do with planning.
It's like not just creating the objects in Gazebo, but then having the objects be able to be like the physical space location you have to be able to be integrated into the planning and control that's being run in the Gazebo.
Okay, so like some standard way for those, the software, the planning software to get information about the environment?
Yeah, because I think right now it's just like if you have maybe you will correct me if I'm wrong, but if you have like a shelf that pops up, like the robots will run into the shelf in the Gazebo simulator, but if it's not represented in whatever they're using to plan or control, they wouldn't know about it.
Right.
So that like loop needs to be closed.
So is Gazebo already provides something? This cost map is something Gazebo provides for others, the robot to use in planning, like about where obstacles are and things.
So Gazebo doesn't give you the cost map, so something else needs to query information from Gazebo in order to create the cost map.
Oh, okay, I see. I see.
Out.
Okay.
Just will you repeat that for the.
Oh, so yeah, for folks on Zoom, so I guess this is like right now robots query Gazebo to get this information, but it's not necessarily up to date with new objects that like Scenic might be adding.
I'm not really sure if it's a thing that Gazebo would change or if it's just like an external thing.
It's probably
External thing.
Okay, great. Yeah. And so I can do a similar roundup of the AV working group session. But just to finish yesterday's last night's discussion, so we had a long discussion about improving documentation and tutorial material. I don't want to repeat it all here. But I think that's a big action item for us going forward. Sridhar had some interesting points and suggestions about not just doing the Scenic NL road to code side of things, but also learning the distributions, the algorithm distributions after that.
And I think there's some ideas that we can pursue there. And then our USC attendees are doing work that can improve the sampling techniques in Scenic. And we talked a little bit about not just connecting that to verify, which is easier, I think, but also within Scenic, like improving the sampling in Scenic. That I think right now is not that easy for somebody to come in and change the sampling algorithm. So that's those are two things for us to think about and work on in the next year. All right, and so so that's all from last night. Does anybody else want to weigh in on any of those discussions from last night? Okay. If not, then I'll quickly summarize what happened in the autonomous driving working group session. Some discussion about maps and making it easier to convert from a map of anywhere on the plan's node network into something that Scenic can import. And I think someone mentioned, I think Eric maybe mentioned that Roadrunner from MapWorld has some capability to do this, but it's a paid license and not entirely. Maybe you can say more, but I'm not entirely clear as to what the capabilities are.
I think it works quite well. I think a lot of the maps that people have brought to us to interface with Scenic are generated using that.
Okay.
But it's just proprietary.
Okay, proprietary and but seems to work pretty well, and people who use that are able to generate maps and then bring it to us to use with Scenic. So that's one software system that seems to be feasible for this process. The other thing that came up was from Sridhar talking about defining high-level predicates to test characteristics of the road network, like is something a two-lane road or a one-way street or things like that. And you can of course define those predicates in the driving domain library, so that might make life easier in terms of modeling and Scenic. We talked about the lanelet 2 parser, which I think might be an action item for development of the year ahead. And then the other thing we talked about was joining forces to create a library of Scenic scenarios, because I think many different groups have built up sets of Scenic scenarios, and we'd like to publish them all in a format that external people can use and can become a benchmark library. I think that kind of rounds it up. Did I miss anything? Okay. Anything else that people want to bring up, discuss, suggest? Yeah, so right. Okay, so so Daniel and I currently have NSF funding primarily to support Scenic, and that's what is helping support these workshops. That's going to run out sometime next year. So so we are actively in the process of investigating how to not just raise funding, which is important, but also develop a structure, a governance structure that can sustain the project past the federal funding, and even beyond our groups at Berkeley and Santa Cruz. So I think we have a lot to learn from the Open Source Robotics Foundation and so forth, but we are investigating, fiscal sponsorship and things like that. In any case, we are open to suggestions and contacts and help from anybody in the community. So let us know if you have any input on that now or later.
Yeah, I guess I'll just add that as part of this NSF project, which has been going on for almost 2 years now, we've kind of in an exploratory manner put together like a governance structure for the project beyond our 2 groups, where we have a steering committee, which initially would be Sanjay and me and Sridhar and Nechmi who would make it. And then, the working groups under that looking at different aspects of Scenic and so forth. And We have our project roadmap and things like that. And we have actually applied to become a sponsored project of NumFocus, which is a fiscal sponsor for many scientific Python packages like NumPy, SciPy, various other things. And we actually were hoping to hear back in time for this workshop, but they're very delayed. But the piece that we still haven't really figured out is, as Sanjit said, how to sustain the project going forward. We've been putting a lot of effort these past 2 years to try to make the project more friendly to outside maintainers, outside our group. So Lola has been working on a lot of infrastructure for continuous integration and testing and triage of issues, and the user forum we created as part of this effort, etc. And the part that we're trying to figure out now is basically how can we get, for example, industry sponsors to help support someone like Lola, for instance, right? A software developer who can work on the parts of maintaining Scenic that we can't, publish papers on, for example, right? But it's not too well suited for grad students to work on that sort of thing. So, we've been looking at how some other projects that have transitioned from academic tools to being some more broadly used and have done this. But as Sanjay said, we're very happy to get advice from people or suggestions.
All right. Anything else the folks want to discuss? Okay. All right. If there is not, I'll just put the workshop page up. And are you still?
I can share.
No, so mine came up.
Oh, okay, yeah. So we added at the end.
So we'd love to get feedback from you. So there's you go to the website, last closing session, we have a link for you to fill out a survey. Should just take a couple of minutes.